In this video, we're going to work a problem where we find the components of a force along random directions. We're going to do this graphically. In most cases, you'll have a Cartesian coordinate system, so in either 2D or 3D, you can represent your forces and directions with components and use the dot product to get components of the forces along any direction. But it's still valuable to practice problems with vectors graphically. You learn a lot of the geometry involved in working with vectors. Also, even with a Cartesian coordinate system, if you're resolving graphically along random axes that aren't perpendicular, then you still may need to use the law of sines or law of cosines to get information. So it's good to practice working with the law of sines and law of cosines and analyzing triangles that aren't right triangles. All right, let's get started. Force F acts on the frame such that its component acting along member AB is 650 pounds. All right. FAB is equal to 650 pounds, directed from B towards A. The required angle, okay, this angle here, and the component will determine the required angle and the component acting along member BC, so FBC, and determine that angle and that force and set F is equal to 850 pounds, and then this angle theta is equal to 30 degrees. Okay, so what's always very helpful is having the direction axes drawn at the tail and the head of the vector. And so we have them at the tail. So if we're going to do this at the head, all right. Okay. Right, because we're trying, these are our directions. And so now what else can we draw? Well, the components of F along these directions, you walk along those directions to get from the tail of F to the head of F. So we know that F is going to be, FAB is in this direction, FAB is in this direction, and then FBC is in this direction. So we walk along this axis and then along this axis. So the lengths of these, this length of this line, the length of this line is 650. The length of this line we're trying to solve for, and the length of this line is 850. So 650, 850. We're trying to find this length, and we're trying to find this angle. And to do that, for problems like this, where since we're dealing with completely random directions, we're most likely not going to have right triangles, we're going to want to use the law of sines and cosines, or law of sines or law of cosines, or both. So we've got two side lengths. So maybe we can use the law of cosines because it only has one angle in it. Yeah, we can, because, okay, we're looking for this here. So in the law of cosines, this is C. We've got A, we've got B, and this C is the angle. This C here is the angle between A and B. So let's go ahead and solve for this length. Okay, so FBC is, okay, A squared, so 650 squared plus B squared minus 2AB cosine of 30. All right. Okay, so 650 squared plus 850 squared minus 2 times 650 times 850 times cosine of 30. $188,042. Well, no. Okay, we got to take the square root of that. Well, no. Okay, we got to take the square root of that. 433.6. Okay, now that's one of the values it was asking us. All right, so now we just need to find this angle. What you can do is look at it this way. It's like you can imagine this is FBC. This is FBA. That's the resultant force. Okay, so this is 30 degrees. And then this must be psi plus 45 degrees. You see? So we can say FBC, so 433.6 over sine of 30 is equal to F, so 850 over sine psi plus 45. So sine psi plus 45 is .980. Okay, so now the inverse sine of this $78.57. Okay, so psi is equal to 33.6 degrees.